Right now, your engine is running on bad data. Not because anything broke, because 5 sensors that nobody ever cleans are lying to your computer every single time you drive. Shops see these codes, skip straight to the expensive fix, and charge you $800 to $2,400 for parts that weren't even the problem. Today, we're going through the 5 sensors that cause the most misdiagnoses in the shop. Rough idle, hesitation, bad fuel economy, check engine codes that keep coming back. Every single one of these symptoms traces back to sensors that just need cleaning. Not replacing. Cleaning. I'm going to show you exactly what each sensor does, exactly what it costs when shops misdiagnose it, and exactly how to fix it yourself before you hand anyone a single dollar. Stay till the end. The last sensor is the one mechanics never mention first, because there's no money in mentioning it first. Let's get into it. The O2 sensor scam. Look, the oxygen sensor is the most replaced in the automotive industry. Shops love it. You know why? Because the part sounds technical, the labor sounds justified, and the customer never questions it. Here's what it actually does. Your O2 sensor sits in the exhaust stream before and after the catalytic converter. It measures oxygen levels in the exhaust gases and sends that data to the ECU. Computers use that reading to fine-tune fuel delivery in real time. Rich or lean, it's constantly adjusting based on what the O2 sensor reports. Now here's where shops get you. Code P0171 or P0174 pops up. System running lean. The technician pulls the code, looks at the customer, says, oxygen sensor failure. Quote, $400 to $600 per sensor. Some vehicles have 4 of them. Do the math. But here's the thing. A lean code doesn't mean the O2 sensor failed. It means the computer saw a lean condition. That lean condition has 6 different causes. O2 sensor is one of them. A dirty MAF sensor causing the computer to underdeliver fuel. That's another. Vacuum leak, another. Shops skip the $0 diagnostic steps and go straight to the $500 part. Real talk, before any O2 sensor gets replaced, 3 things should be checked first. Intake leaks, fuel pressure, and MAF sensor condition. Takes 20 minutes, costs nothing. Shops skip all 3. A customer came in after a dealership replaced both upstream O2 sensors on his Tacoma. $780 total. Lean code came back within 300 miles. Same code, fresh sensors. I checked the MAF, contaminated. Cleaned it in 15 minutes. Lean code never came back. The O2 sensors he paid $780 for were functioning perfectly the whole time. So before you authorize any O2 sensor replacement, ask one question. Did you clean the MAF sensor first? Watch how uncomfortable that makes them. The throttle position sensor nobody talks about. So here's one that gets misdiagnosed as a transmission problem more than anything else. Customer comes in, says the car hesitates, jerks between gears, loses power on acceleration. Shop hooks up the scanner, sees erratic throttle data, and immediately starts talking transmission service. $300 minimum just to look at it. The throttle position sensor. TPS. It sits directly on your throttle body, monitoring exactly how far open the throttle plate is at any given moment. You press the gas pedal. The TPS tells the ECU how much you pressed it and how fast. ECU uses that to calculate fuel, ignition timing, and transmission shift points all at once. That last part is why it gets misdiagnosed. Transmission shift points. When the TPS sends erratic data, the transmission shifts at the wrong time. Too early, too late, or sometimes a hard clunk between gears. Feels exactly like a transmission problem. It's not. It's a $180 sensor giving bad data. But before replacement, even the throttle body itself. Carbon builds up on the throttle plate and bore over 50,000 to 60,000 miles. That carbon physically interferes with throttle movement. The TPS reads inconsistent position because the throttle plate is actually moving inconsistently. Sticking slightly, releasing, sticking again. Now here's where it gets expensive. Shops skip straight to throttle body replacement, $400 to $900 depending on vehicle, or they go after the transmission. Meanwhile, a $6 can of throttle body cleaner and 20 minutes fixes 70% of these cases completely. The symptoms are specific. Hesitation on light acceleration from a dead stop. Jerky gear changes especially between first and second. Hunting idle that surges up and down, and sometimes a total loss of power that comes and goes randomly. Engine feels fine 1 minute, gutless the next. That random power loss is what scares people. They think engine failure. They authorize anything the shop recommends because they're scared. Shops know this. I had a customer convinced he needed a new transmission. $3,200. Quote, he'd been driving it for 2 months, getting progressively worse. Cleaned the throttle body, cleared the TPS adaptation, values with a scan tool. Took 25 minutes, drove perfectly. That $3,200 transmission was never the problem. A dirty throttle body was sending the TPS into fits. Clean the throttle body before anyone touches your transmission. Non-negotiable. The map sensor. Most mechanics confuse with the MAF. Here's where it gets interesting. Most people have never heard of the MAP sensor. Even some mechanics mix it up with the MAF. They sound similar, they both measure air, and misdiagnosing one for the other costs you every time. MAP stands for manifold absolute pressure. Instead of measuring airflow directly like the MAF does, it measures pressure inside the intake manifold. Your ECU uses that pressure reading to calculate air density and determine fuel delivery. Different approach, same goal, get the right amount of fuel into the engine. Now here's the thing, not every vehicle has both. Older vehicles and many turbocharged engines run a MAP sensor instead of an MAF. Some modern engines run both, simultaneously. If your car has a turbo, the MAP sensor is even more critical because it's also monitoring boost pressure. Bad MAP data on a turbocharged engine means the computer can't see boost correctly. Power drops, fuel trims go crazy, and the turbo feels like it's not even there. The symptoms overlap heavily with MAF problems. Rough idle, poor acceleration, bad fuel economy. But there's one symptom that points specifically to the MAP, surging under load. You're on the highway, steady throttle, and the engine pulses. Not misfiring, just surging rhythmically. That's the MAP sensor losing pressure signal under sustained load. Here's how shops get you. MAP sensor failure throws codes P0105 through P0108. Technician pulls the code, quotes a new map sensor. $150 to $300 depending on vehicle. But here's what they skip. The map sensor has a vacuum line or direct port connection to the intake manifold. That connection gets clogged with carbon and oil residue. Blocked passage means bad pressure reading. Clean the passage, problem solved. New sensor completely unnecessary. So look, before replacing a map sensor, 2 things need checking. First, inspect the vacuum line or port for blockage. A thin wire or compressed air clears it in 2 minutes. Second, check for intake manifold vacuum leaks. A cracked hose anywhere between the throttle body and engine creates false pressure readings that make the map sensor look like it failed when it didn't. Customer had a 2016 Subaru WRX, turbocharged, complained of boost that felt weak and surging at highway speed. Shop quoted a new MAP sensor and a boost leak test package, $680 total. I checked the map sensor port first, completely blocked with carbon. Cleared it with compressed air and a thin pick. Took 4 minutes. Boost came back immediately. Surging gone. That $680 repair was a 4-minute cleaning job. But the MAP and the MAF, they're both just appetizers. The next 2 sensors are where the real money gets. Wasted. The crankshaft position sensor that terrifies everyone. This one is different, because when this sensor starts failing, the symptoms are so dramatic that people panic. And panicking in a dealership waiting room is the most expensive thing you can do. The crankshaft position sensor, CKP. It sits near the bottom of the engine, monitoring the crankshaft as it spins. It tells the ECU exactly where each piston is in its cycle at any given millisecond. Timing of fuel injection, timing of ignition spark, both depend entirely on this sensor. Without accurate CKP data, the computer is guessing, and engines don't run well on guesses. Here's what failing looks like. Engine cranks but won't start. Just turns over and over, nothing catches. Or it starts fine cold, runs perfectly for 20 minutes, then suddenly stalls at a traffic light. Won't restart for 30 minutes, then starts again like nothing happened. That heat-related intermittent stall is the signature symptom. Shops see it constantly. Now here's where people get destroyed financially. Engine won't start, the customer panics, tow truck to the dealership. Technician hooks up scanner, sees no crank signal, starts talking about timing chain issues, engine damage, worst-case scenarios. Customer authorizes a $2,000 diagnostic deep dive because the car won't start and they're scared. Real talk, a failing CKP sensor is one of the cheapest fixes on this list. The part itself runs $40 to $120 on most vehicles. Labor is 1 hour maximum because the sensor is externally mounted. Total repair, $150 to $250 at an honest shop. But scared customers in dealerships don't get honest shop prices. But before even replacing it, the connector. The CKP sensor connector lives in a brutal location. Low on the engine, exposed to road debris, oil spray, heat cycling constantly. Connector pins corrode. Corrosion creates resistance. Resistance creates intermittent signal loss. Clean the connector with electrical contact. Cleaner, apply dielectric grease, reconnect. Sometimes that's the entire fix. $3 repair on a symptom, shops quote $2,000 to diagnose. There's another one that gets missed. The reluctor wheel. The CKP sensor reads a toothed wheel attached to the crankshaft. If that wheel picks up metallic debris or gets a damaged tooth, the sensor sends erratic signals even though the sensor itself is perfectly fine. Shops replace the sensor, problem comes back, customer pays twice. A guy towed his 2014 Ford F-150 to 3 different shops over 4 months. Intermittent no start, always heat related. Always started after sitting 30 minutes. First shop, fuel pump replacement, $620. Problem came back. Second shop, ignition control module, $480. Problem came back. Third shop quoted a timing chain inspection, $400 just to look. He called me instead, cleaned the CKP connector, applied dielectric grease, cleared codes. 18 months later, 0 issues. His $1,100 in previous repairs fixed nothing, because nobody checked a corroded connector first. So when your engine pulls a dramatic no-start or a heat-related stall, don't panic. Panic is what makes that repair $2,000 instead of $80. Check the CKP connector first, always. The MAF sensor, the one they never clean. First, we've been building to this one, and here's why it's last, because this is the sensor that exposes exactly how the diagnostic scam works. Not sometimes, every single day in every single shop, on every single rough idle complaint that walks through the door. The mass airflow sensor, MAF. It sits between your air filter and throttle body, measuring exactly how much air enters the engine. Your ECU uses that number to calculate fuel delivery. Right air reading, right fuel amount, engine runs perfectly. Wrong reading, everything breaks down. Too much fuel, engine runs rich, stumbles and shakes. Too little fuel, runs lean, misfires and hesitates. And every symptom points somewhere expensive. Here's what makes it different from every other sensor on this list. The MAF uses sensing elements thinner than a human hair to measure airflow. Microscopic. And over 30,000 to 50,000 miles, a film builds up on those elements. Oil vapor from the PCV system depositing microscopic droplets. Dust particles are slipping past the air filter and sticking. Carbon working backwards through the intake. You can't see it, no warning light, no dramatic failure, just slow, consistent contamination turning accurate readings into garbage data. And that garbage data triggers everything. lean codes, rich codes, O2 sensor codes, catalytic converter efficiency codes. The computer sees bad air data, tries to compensate, fails, throws every code it has. Shops pull those codes and see a menu of expensive repairs. They never look at the sensor sending the bad data in the first place. This is the scam, and it's not always malicious. Sometimes technicians are genuinely undertrained, but the result is identical either way. Customer comes in. Rough idle, check engine light, hesitation on acceleration. Technician pulls codes, P0171, system running lean. Maybe P0420, catalytic converter efficiency. Proper diagnosis starts with the MAF. But there's no profit in a $15 cleaning service. So instead they recommend upstream O2 sensors, fuel injectors, intake manifold inspection, catalytic converter. Quote, comes back $1,400. Sometimes $2,400. Customer authorizes it because they trust the expertise. New parts go in. Idle improves slightly because fresh O2 sensors help the computer compensate better for the still dirty MAF data. Customer leaves satisfied. 3 months later, same symptoms. Same codes, more diagnosis fees, more parts. The cycle continues until someone finally cleans the MAF sensor and the whole thing disappears in 15 minutes. I've seen this exact cycle play out on a 2019 Mazda CX-5. Owner paid $2,400 across 2 dealership visits. O2 sensors, fuel injectors, diagnostic fees. Rough idle, kept coming back. I cleaned the MAF sensor in her driveway. Idle smoothed out instantly. Fuel economy went from 25 back to 28 miles per gallon within 2 tanks. Code never returned. Every dollar she spent at the dealership was chasing symptoms of a dirty sensor nobody touched. Now here's how you clean it yourself. Buy MAF sensor cleaner specifically. $8 at any auto parts store. Not carb cleaner, not brake cleaner, not throttle body cleaner. Those leave residue that destroys the sensing element. MAF cleaner only. Turn off the ignition. Disconnect the electrical connector. Press the release tab. Don't yank the wires. Remove the 2 or 3 small screws holding it in place, usually T20 or T25 Torx. Slide the sensor out carefully. Handle it like glass. Take it outside. Hold it with the sensing element facing down. Spray 3 short 2-second bursts directly on the element. Let it evaporate 30 seconds between each burst. Never touch the element with anything. No swabs, no brushes, spray only. Let it dry completely, 5 minutes minimum. Reinstall, reconnect, and disconnect the battery negative terminal for 10 minutes to clear old fuel trim adaptations. Reconnect. Start the engine. Let it idle 2 minutes without touching the throttle. Watch it smooth out. That's it. That's the $2,400 repair. 15 minutes and $8. And next time, a shop quotes you $800 for rough idle, you look them in the eye and ask one question. Did you clean the MAF sensor first? Watch what happens to that quote. Look, 5 sensors. All of them are misdiagnosed daily. All of them fixable before you spend a single dollar at a shop. Clean the throttle body, check the MAP port, inspect the CKP connector, and clean that MAF sensor before you authorize anything. Drop your symptoms in the comments right now. Rough idle, hesitation, bad fuel economy. Tell me exactly what your car is doing and I'll tell you which sensor to check first. Free diagnosis right here. If this saved you money today, subscribe. Because next week we're exposing another repair shop's charge thousands for that takes 20 minutes at home. You don't want to miss it.